Welcome guys to another video. I'm still out of town. I'm in Mexico. I decided to do another topic for you. So this is going to be start off with our lesson 2 series. I believe there's 3 topics. This is topic A and there's B and C. I did prefer longer videos opposed to the quick videos I was making on just a selection of items. I found it better to just do them all in one go since I don't like to be unorganized when I'm on YouTube. So that's what we're going to be doing. So let's go over system devices. So in topic A, we have the introduction to the whole lesson. Um, Install and configure power supplies and cooling, the PCUs, what wattage rating and why it matters, power supply connectors, and then the cooling systems. So as you all know, computers like to generate heat and you need cooling. But more importantly, understanding the power requirements of all the components and maximum power output is crucial in managing new builds and upgrades and repairs. So, if you have, say, a power supply that probably the highest I've seen was 700 watts, and that's mostly just for gaming PCs. Those watts do matter because each individual part takes, I guess, a shared amount of that wattage. And of course, we just talked about the heat, which you run you're risking it damaging the components if you do not have the adequate cooling or power. Let's go to the next slide. So power supply units delivers direct current, low power to the PC components. A PCU contains a rectifier to convert AC building power to DC voltage output. Transformers to step down to lower voltages, filters, and regulators to ensure consistent output voltage levels. And of course, it also has a fan which dissipates the heat that's generated as the electricity is moving from one end to the other. The power supply size and shape determines compatibility with the system case and its motherboard. But most PCUs designed um, are used for desktop PCs based on ATX form factor. Another keynote, I think this is on the exam, is that the differences between voltages. So in North America, I believe it's 120, as it says right here. I can't really point to it, but where you see the 120 VAC loan line, it's only really used in North America. In the UK, it's a 230 VAC, that's the high line. And it is used in North America, but only for data centers that because they use it for more high efficiency. Some of that auto switch was pretty cool. But usually in the back has the switch. I think I even saw this on a 3D printer. I had to make the switch to I believe 110, but that was a 3D printer. That wasn't really a desktop computer. The input operating voltages should be clearly marked on the unit and accompanying documentation. That's where you can find out if you want to check out your PC, whether it's 120 or 230. You can just go on the back and you can see the switch now. If you live in North America, it's pretty safe to say you have 120, and vice versa. Again, the low line range is 110 to 127, and the high line range is 120 and 240. Okay, that's what I saw on my 3D printer. It was 110. I think it's 220. It's kind of weird. AC voltage supply varies by country by the nature of AC distribution circuits. Consequently, PCUs have quite a wide tolerance in each band. So wattage rating. Excuse me, I just need to put in a couple of information. Okay, we're good. For the wattage rating, we just saw. Power is rated by which things generate use energy. Power is measured in watts. As you can see, usually says 300 watts when you buy PCU. This is calculated um, by multiplying the voltage and the current. A PC must be able to meet the combining requirements of the PC components. PC designs used for standard desktop PCs typically rate around 200 and 300. For enterprise workstation PC and service, often units rate over 300 watts to meet the demands of multiple CPUs, additional memory modules, disk drives, tape units. And gaming PCs might require 500 or better power supplies to cope with the highest specification CPU and graphics cards. Oops. The power requirement different components varies widely. For example, CPUs can range from 17 watts to over 100 depending on model. If you're building or upgrading a system, the simplest way to work out the power requirement is to use an online calculator. It's pretty true. The power output is not the same as the power the PCU draws from the grid power. If a PCU works around 75 efficiency, a 300 watt supply would draw 400 watt from the outlet. The extra energy is mainly lost in heat. And an Energy Star 80 Plus compliant PCU must be 80% efficiency at 20 or 100% load. So that's if you're buying one, you might see that marketed. Other than that is voltages. I'm not really an electrical engineer or handle a lot of electricity, so you guys might not. You guys may know more than me. When specifying a PCU for a system with high power requirements, it is important to assess the power distribution for its output voltages 3.3 VDC 5, 12. Distribution refers to how much power is supplied over on each rail. A rail is a wire providing current at a particular voltage. The following table shows as an example of how a power distribution for a PC might be configured. Here we see a table, 3.3. Rail probably go up to 130, 5 the same. Plus 12 is 396, and negative 12 is 9.6, and zero point 0.5 is standby, is just 12.5. Both the output of 3.3 voltages and 5 voltages have combined limit for a computer output rating of the 12 VDC rail or rails is the most important factor, as 12 VDC is most heavily used. Going into the power supply units, or going much deeper into detail. Actually, this is a repeated slide. I'm sorry for that, guys. So power supply connectors. Each PCU has a number of power supply connectors. Not all components use power at precisely these voltages. Voltage regulators are used to correct the voltage supplier from the PCU to the voltage required by the component. The motherboard's power port is referred to as P1 connector, a power supply. We also have a number of Molex and SATA device power connectors and 4, 6, 8 pin connectors for use with CPU and PCI adapter card power ports. I think we talked about the SATA and the hard disk in our previous module. Okay, there's two main types, 20 pin to 24 pin motherboard adapter. The ATX PCU standard has gone through several revisions specifying different connector form factors in the original ATX specification. A P1 connector is 20 pin, 2 times 10. So, in the next slide, they show a diagram of it. You can see, and I think kind of blacked out. Not really blacked out. It's just I'm outside, so I can't really see the boxes, but you should see 20 boxes. And the wires for the black insulation, yeah, the numbers, I mean, the colors do matter, Mason. I was thinking about Black Ops 2. I mean Black Ops 1. So yellow are 12 volts, red are 5 volts, and orange are 3.3 volts, and the black, of course, is ground. Most systems are now based on the ATX 12 volt version 2 specification. This defines a 24 pin 2 times 12 P1 form factor to replace the 20 pin one. Some PCUs have a 20 plus 4 pin adapter cable for compatibility with older motherboards with that 20 pin port. Okay, that makes much more sense why what the difference was. When I was doing one of the labs, I remember I noticed there was an extra cable and I had to fix the issue, so I just had to connect the last 4 pins to the cord, the slot. And there's red and pink for some reason, also blue. Sure, the colors do matter. I just don't know why they are that color. Going to the last three slides, modular power supplies have power connectors, cables that are detachable from the unit, reducing the number of cables to a minimum requires minimizing glare within the chassis. Improving airflow and cooling, for example, a non-modular PCU might have five or four Molex and SATA device power connectors, but the PC might only require two of them. With a modular PCU, the unnecessary cables can be removed. So this allows for a more cleaner setup and less clutter that could affect the airflow coming in. Okay, I don't think that's the last three. Redundant power supply. A computer system may be fitted with two PCUs, with one acting as a failover redundant power supply. This could also be connected to a different grid power circuit. A redundant PCU configuration requires a compatible motherboard. This configuration is more commonly found on server systems than on desktop PCs. On a server, typically each PCU plugs in the backplane. Backplane is hot swappable. This allows a faulty unit to be removed and replaced without having to open the case without the server ever losing power. So if you didn't catch that, um, it could looks like it could be connected with a no, it didn't say that. Okay. So the power supply is kind of outside the case and it looks like it's just connected on the motherboard or it's just well, it has to be connected to the motherboard obviously for it to be redundant. And I'm not sure if it can even use the PCI Express bus uh, as a power source. So it depends on the motherboard. If it has two, you could just plug one in when you're building PC, and we have one outside which you just connect. Okay, fan cooling systems. Yeah, this is pretty important. Components in the computer system emit heat because of some degree of resistance when the electricity current passes through them. Without a cooling solution, this heat will raise the temperature of each component, therefore damaging it or causing errors. The issue particularly affects CPUs, while Intel and AMD are both focusing on making new CPU designs more thermally efficient. And all CPUs require cooling. As well as the CPU, components such as memory modules and graphic adapters also require cooling solutions. But what is a heat sink? It's usually that weird block that is made out of copper. Yeah, it's a block of copper, aluminum with fins. The fins expose large or surface area to air around the component to achieve a cooling effect by convection. The heat sink is affixed to the surface of the chip using thermal paste to ensure the best transfer of heat by eliminating small air gaps. Or a thermal pad does the same thing, but the pad is a compound that is solid at room temperature but softens when heated. This can be easier to apply, but does not always perform as reliably. I think thermal pads are largely used for components that don't really overheat a lot. I think I had one of my course instructors note that an ME uh, drive has on there. It has a thermal pad, sorry. My laptop has that too. It's very squishy, depending on what you got. It can be very different. Also, if you look at your Xbox Series S, you take it apart, you look on the power supply, you'll also see a thermal pad or a thermal round, which is different. But they could use a thermal pad um, the same way it can use a thermal round. Oop, went too far. Here's just a diagram. The thermal pad usually goes here. There are various mechanisms for clamping a CPU heatsink to the motherboard. There may be a retainer clip or push pins. Push pin can be released and reset for insertion by making a half turn with a screwdriver, or you can do it with your hand. So these are the last two slides: fans and liquid cooling. Fans, a heatsink is a passive cooling device. Passive cooling means that it does not require extra energy to work. To work well, a heatsink requires good airflow around the PC. It is important to try to keep cable color. That's where the modular power supply comes into play. You don't have much cable clutter if you have one of those. To a minimum and to ensure that spread adapter slots are covered by blanking plates. Yeah, that's another thing to keep good airflow. If there's any like big holes, I mean by big holes, I mean like slots where you could put adapter cards, having a blanking plate there will help it to cool off. It's pretty recommended, maybe like highly suggested as well. I don't know. Many PCs have components that generally generate more heat than can be removed by passive cooling. A fan improves airflow, which helps to dissipate heat. Fans are used for power supply and chases exhaust points. The fan system will be designed to draw cool air from the low vents in the front of the case over the motherboard and expel warm air from the fan position at the top of the back of the case. Most heat sinks are fitted with fans to improve their cooling performance. The fan's power connector must be plugged into a motherboard fan power port. Therm Thermometer sensors are used at each fan location to set a proper speed and detect whether a fan has failed. Some chassis designs incorporate a plastic shroud or system or baffles to cover the CPU and generate the flow of air. The shroud is usually attached to the case using plastic clips. Both fans and heat sinks become less effective if dust is allowed to build up. These components and any air vents should be cleaned periodically, either manually with a soft brush or a compressed air, or using a vacuum cleaner approved for use with PCs. Yeah, usually compressed air is the most, I guess, cheapest option, or you could just take it apart and use the soft brush. And yeah, don't use like your household vacuum cleaner to clean your PC. You have to use one that's improved. Um, I believe the reason it's that's there is because the vacuum creates static electricity, which could damage the components. Or I think another reason I heard was it just moves the dust everywhere. Doesn't really clean it up. Obviously, you could remove big chunks of dust with a vacuum cleaner, but it's not recommended. Alright, this is the last one. Liquid cooling systems. PCs used for high-end gaming may generate more heat than basic thermal management can cope with. PC used where the ambient temperature is very high may also require exceptional cooling measures. Excuse me, can't speak right now. A liquid-based cooling system refers to a system of pumping water around the chassis. Water is more effective coolant than air convection, and a good pump can run more quietly than numerous fans. An open-loop liquid-based cooling system uses the following components: the water loop tubing, the pump push, the coolant added via the reservoir around the system. Water blocks and brackets are attached to each device to remove by convection. These are attached in the similar to sink heat fan assemblies and then connected to water loop. Okay, that makes sense. So there's some like thermal, I guess, or I guess just convection connector that the water blocks have that are connected to the components. Radiators and fans are positioned at air vents to dispel the excessive heat. There are also simpler closed loop systems that installed to a single component CPU or GPU only. An open loop system will usually need draining, cleaning, and refilling periodically. It is also important to keep fans and radiators dust free. The system should also be drained prior to moving the PC to a different location. Uh, that's it. Thanks for watching. Just follow me on um, YouTube and make sure you like and subscribe. I will be going over the next topic after this video, and you should see all these videos come out at once because I don't have good internet where I'm at. So I'm gonna upload them when I get back to the States. Peace out.